Question number 7 of the PhilNITS FE afternoon portion of the exam. In this question, we are being asked something about the heap data structure. And if you've taken any of those data structure classes, then this should be something that you already know of. If not, the description explains what it's supposed to be. And really, before taking the exam, I think that you might as well review data structures and algorithms so that when you take the actual exam, this is something that you already know, and it would make things much faster for you to understand and figure out how to solve the problem. And usually the concepts that they put here, they wouldn't really change any of those parts in the concepts just to see if you can adapt to the change. And in this case, for example, a heap data structure that's using a complete binary tree wouldn't necessarily use a totally different type of implementation. So if you understand what a heap is supposed to be, then I think it would be really faster for you to understand what's happening. Now in my case, what I did was to quickly look at this diagram here to see that a heap is done in this way, and then went into this part where you got the heap sort explained, because what we want to do is to sort the elements in ascending order. Now afterwards, I had to know what the question was, so I looked at the part here where you got the function called swap and the blank there for the question. We got to know what is the correct equation that would fit in this portion of the code. Now remember that a swap is supposed to exchange two values with each other, and in this case too, we gotta remember that the programming language that it's using is in C, C++. And years ago when I took the exam, I opted to do the Java programming language related questions, but because we're reviewing for the exam, then might as well see if we can figure out how to answer it. Now in this case, what we need to do is to understand that we have to change a value, like for example a, and make its value b, and for b we need to make it a. Okay, and the reason why we have to do that is if we look at the diagram here again, we see that if we start from the leftmost, and in this case the value is 15, we see if there's any number greater than it, and if there's none, then we put it to the rightmost. And that's why we got the sorted portion here saying that 15 is already sorted. Now the next part here is that remember that because we did the swapping 15 and 3, then 3 would be here. We have to, it says here, fix the order again. And that way we got the heap fixed. That's why 3 is again at the rightmost and 10 is on the leftmost. Okay, and again what we need to do is to sort the elements in ascending order. Okay, and in this case what we have is it's in reverse, and so that's why we have the heap sort to help us with that aspect. And if we're starting for the leftmost again, it's 10, and we see if there's any number greater than it, and if there's none, we put it to the rightmost, and that's why we got 10 and 15 here. And again we have fix needed, and again what we get is a heap fixed where 3, which was swapped with 10, will have to be put on the rightmost too. Okay, so that's the part where you got the swapping. Now once we understand that there's a swapping thing going on here, then how do you know which one is the correct answer? Well, if you look at what's happening here, inside you got a t variable which is supposed to be a, a data structure where you got values for the t, and we're giving it the the pointer to a, which means that if we see what's inside it, then we'll get the value um, that is a, because we're giving it the pointer to a, right? The location where in memory you got the a, we're saying that t would be able to point to that location. Okay. Now in this case, the next thing that we need to do is we we have the a here, and then the other value that we need to swap with, in this case it's p. Then we give the a here, the pointer to a, the value that points to b. Okay. Now for the last part, what we need to do is, because we've given the pointer to b to the pointer to a, then the pointer to b has to get the value of t. Okay, so in that case, we have the swapping already. Now, when I was doing this, I think I had this question also, where what if you have an asterisk, a pointer to t? Would that also work or not? Now, in this case, it seems that it's not the correct answer, because otherwise, if you're pointing to um, the the t, in this case, pointer to t, which points to a, then you'll get the value which is gonna be, in this case, gonna be classified as unary asterisk. So it's an invalid type, and that's why um, I ended up choosing this one, because first also there was no asterisk b equals asterisk t at all in this set of choices. And like what I said a while ago, also, if there's also that possibility, then what could be the result? And it turns out that you'll get an unary asterisk for doing that. I think that it's it's a little bit confusing at times, this concept about pointers, and I think that the way I use C++ is pretty much how things work with Java, because you can use it in such a way that um, the values that you put into a function, if you change it, then if you go outside the function, the value will still keep the change, right? Because there's a way for you to avoid changing the value that you've passed to the the function, right? And in my case, I focus more on how Java does it, because really having all these asterisks, and then I think later on we'll see an ampersand, can be quite confusing. And I think in this case too, I knew years and years ago that if I were gonna answer the C++ portion of the exam, I needed a computer to test it. And in this case, I also had to use the computer just to see what would be the result, and it told me that it's going to be a unary asterisk if we attempt to have something like asterisk p is equal to asterisk t. Okay, and I think that should be it.